Good evening, ladies and gentlemen. This is Engineer Patrick Egon. Patrick Egon is an electrical engineer. Today we'll be talking to you about how to terminate a distribution board. If you are new to our channel, this is Untitled Patrick Egon. Kindly share this information if you find it good to you, and also remember to subscribe to the channel as support. So today I'll be taking you on how to terminate a distribution board. And maybe before we do that, I need to classify some few things. This is a distribution board. It's a three-phase system. Downwards, you'll be having what is called a CCU. It is a consumer control unit. Then above this, you'll be having what is called a sub-distribution board, which is higher in rating than this, but lower compared to the main control panels, which you'll be having in a major powerhouses. So I want us to look at parts of our distribution board. So number one, we'll be having the main mechanical frame. You have these holes. You can get the holes, and so that you can get your piping or the wiring system going through that. You can only use a knockout system. Inside it, you have these terminals. So this is a warning. In my case, this one has not been terminated. So this is a dead circuit. So whenever you are doing any electrical termination, please don't do what I'm doing, because I'm working on a dead circuit, lest you'll have yourself electrocuted. So this is a, I think, terminal in our case. This will be our neutral block. And as you can see, we have taken our neutral block from one of the terminals of this MCB. Then you have these rails. In our case, all our MCBs and RCDs and RCBs will be mounted on this particular rail. We have a mounting mechanism. When you want to unmount them, you just unlock in case you want to check and all that. So this is an MCB. This is an RCD. Some other people call it RCB. You'll have RCBO in other systems, and this is an MCCB. So there's a difference between an MCB and MCCB. The main difference is the interrupting current capacity. For this, you use mostly for domestic application, where you don't have a lot of current needs. And then MCCB, you will need it for larger capacity needs, that is industrial application. The other difference is how the two work when it comes to interrupting our capabilities. This one is it's a movable system. This one is a fixed system, the on-off capabilities. So those are some of the difference you'll have on that. So when you are terminating your cable, you'll need some tools first to mount this. As you can see, maybe the cameraman will be able to focus here. We have fixed this using this a screw. So you may use, this one is provided with screws when you're buying it. You may decide to use a rope bolt or any other mechanism. You can be able to use it so that this is mechanically fixed. And this is to avoid any situation whereby maybe this one may fall, or maybe this one may vibrate or do anything which will temper on your circuit, the health of the circuit, and therefore bringing an electrical problem, an electrical threat to your users. So you'll need a lot of tools when doing this. Number one, you'll need an electrical drill. So you may use a core drill, please. In our case, this is an electrical drill. You'll need an hacksaw. This is one that is used to cut your cable. You will need a meter, electrical meter. You'll need these are electrical pliers. This is a bending spring. This is especially useful when you are doing the ducting. So in case you need that. Then here we need, this is a screw. This is also a measuring device. This one will give you the dimensions when you are fitting that. This one as well goes with this. This is a spirit level, because your work should be neat enough. Then this is electrical insulating cables. You can see these are tapes, ducting tapes. Number one is yellow, blue, red. These are important because apart from providing the insulation, they'll give you the color codes. As you can see from our circuit, we are doing RYB, which is very important. Number one, it alerts any electrician who will be coming into this board that this is a termination. In case you are doing phase sequencing or anything, and you want to troubleshoot a particular phase, it is quite easy to show that. There are some other items which I'll just show two of them. You may use cable sleeves and all that to do your dressing, but this is an important material. This is what is called cable lugs. Cable lugs, you will need cable lugs so that when you tighten your cable inside here, they act as firm controls. Then you'll need a cable gland. This one, as you can see, this is it's firm. So a cable is firmly held to the board. Let me show you a cable gland from the external end. This is the cable gland we are talking about. So you use it to mount your cable. You just open one side and all that. The cable will go through here. Then you ensure that you have insulated this using a sheet. As you can see, this is neatly done on this end. So that is basically it. When you are mounting your cables, you need to decide the sequence depending on the country you are or the process you want. So if you do RYB, you should stick to RYB, because okay, in our system we have an automatic phase balance circuits, but there are some issues. There are some instances you will need to do the phase balancing as a technician. So it is good to balance. For example, if you are doing 10 loads in the R phase, you should be able to do 10 loads of equal magnitude on the Y phase at the same time on the yellow and the blue phase. The reason is you will want to maintain the correct line-to-line voltage, the correct phase voltage, so that your system should not have voltage imbalances which may affect the operation of your machines. So basically that is it. This earthing will be terminated to, we are having terminals on the outside section where we are going to terminate our earthing cable. You will need to mount, you will need to bond the earthing to your board, and as well to all the exposed systems. So I want you to have a look at this.